Alright, it's another day. It's actually June 27th, 2021 now, and I'm gonna be grinding Java again. This time I'm not gonna be streaming on Discord, so you won't get the weird Discord sounds. Yesterday, if you remember, I finished up to here, so today my goal is to finish all of this, and I realize I don't need to do 2.11 because that's actually a quiz and I'm going to be doing that in class some other time. So yeah, let's get started with string methods. Also, the reason why sometimes I pause the video during watching these videos is I'm taking notes on the videos actually.
Hi, in this lesson, we'll take a look at some methods we can use with strings. Let's go. As we learned in the last lesson, strings have associated methods that can be used to provide us with information about them. In this lesson, we'll dive a little deeper into this topic and discuss other useful methods we can use with strings.
Also, I'm gonna start writing all the methods I find in the back of my notebook. That way I don't forget all of them. So
In order to best utilize these methods, we must understand how strings are structured. We can think of strings as a sequence of characters. Each character occupies a specific place in that string, which is called the index. The letter H is at index 0. The second letter L is at index 3. The index will help us to access different parts of any string. Each string starts at index 0, and the final index of a string is the number of characters in the string minus 1. We can use the method char_at to access a specific character in a string. In this case, if we write stir.char_at1, we are asking the program to return the character at that specific. Index. In this case, E is the character found at index 1. Let's take a look at some other string methods. We'll start with .length. The .length methods. found at index 1. Let's take a look at some other string methods. We'll start with dot length. The dot length method returns the number of characters in a string object. Next is dot substring. Substring, which is a little more complicated. Let's take a look. The substring method returns the substring beginning at index from and ending at index 2 minus 1. Remember, strings are immutable. This means when you make a string, you can't change it. So if you call substring and get a shorter string, it is a new string. The first value given is inclusive, meaning it is included in the resulting substring. The last value is exclusive, meaning it is not included in the substring. This method call would result in a substring with the letters G, O, and O. We can use the parameters index and index plus 1 to get a single character in the string. What value would be printed from this code?
It looks like it would just print the letter A.
The letter A is the character found at index 6, so that is what would be printed. Since the method calls the first index inclusively and the second index exclusively, we are really looking at what character or element is at index 6. If we use the substring method with only one parameter, the substring will start at the given value and continue to the end of the string. This is a great example of method overloading. The substring method has multiple signatures that allow users to input different parameter values that help improve the functionality of the method. As we've seen, adding a second int value specifies where the substring should stop, and omitting the second value indicates that the substring should run all the way to the end of the string. This demonstrates how method overloading can improve the usability of a method. So when we use one parameter of 5, the substring will start at index 5 and continue to the end of the string. What would happen if we entered a parameter value that is beyond the index positions of the given string? A string object has index values from 0 to length minus 1. Attempting to access indices outside this range will result in an index out of bounds exception. An index out of bounds exception is the computer's way of telling us that something went wrong while trying to access an index because it was out of bounds. The next method we'll look at is .indexOf. The indexOf method returns the index of the first occurrence of the given. given string on the called upon string, or a -1 if the string does not exist within the called upon string. It's important to note that the index of method is case sensitive. Typing in capital D in this case will yield a result of -1 because the character is not found in this string. Even though there are two instances of a lowercase d, the index value 3 is returned because that is the first index. Next, we'll look at the .equal method. The equal method will return true if the given string is equal to the method. The equal method will return true if the given string is equal to the one the method is being called upon. Otherwise, false will be returned. Is equal to the one the method is being called upon. Otherwise, false will be returned. For strings and other objects, we use the equals method to compare whether two values are equivalent. We do so because objects cannot be compared using two equal signs. We will go into further detail about why that's the case later, but for now, just know that string other objects rely on the equals method to determine if two values are the same. The final method we'll look at is compare to. Compare to compares the value of the first character that is not equal in both strings. It returns a numerical value based on the comparison because character values are actually numerical values. Behind the scenes, individual characters are actually Unicode numbers. Java uses Unicode, which assigns a number for every possible character, which includes ASCII and other characters from languages around the world. For a computer to be able to store text and numbers that humans can understand, there needs to be a code that transforms characters into numbers. The Unicode standard defines such a code by using character encoding. The reason character encoding is so important is so that every device can display the same information. A custom character encoding scheme might work great on one computer, but problems can occur if you send that same information to someone else on a different computer. Here's another representation of the chart from the slide before. Each character you send character encode forms keyword and code because both strings. Rely on the equals method to determine if two values are the same. Compare to, the final method we'll look at is compare to. The final method we'll look at is compare to. Compare to compares the value of the first character that is not equal in both strings. Actual size of human. The reason value. The value of each values than their lowercase partners. The compare_to method calculates the numerical distance between character values. Let's take a look to see what happens when we compare uppercase D to lowercase d. The uppercase D character corresponds with a numerical value of 68. The method takes this numerical value and uses it to calculate the distance from the second string object. To compare them, the numerical value of the second character is subtracted from the first. Since the second value, lowercase d, has a numerical value of 100, the method will use that to compare the two values. When 68 is subtracted from 100, the resulting value is -32. This indicates that the original string object is lexicographically lesser than the second string object. The -32 value indicates that the numerical value of capital D precedes the numerical value of lowercase d by 32 characters. Each character of both the strings is converted into a Unicode value for comparison. If both the strings are equal, then this method returns a 0. Otherwise, it returns a positive or negative value. Compare_to is case sensitive, since the ASCII table is case sensitive. Anything after the first differing character will not be compared, whether one string has more or less characters that are equal or not. The integer given in the result is based on the difference in value of the characters in the ASCII chart. Now that we've learned about some of the methods, it's important that we learn a little bit about where the string class can be found. The string class and all of its associated methods
that makes sense. Because, yeah, it has to come from somewhere, right?
are part of a package called java.lang. A package is a group of related classes, along with their methods, fields, and constructors. Packages are part of a programming library. We can think of a programming library the same way that we do a regular library. It's a collection of written works created mostly by other people. While normal libraries have books, programming libraries are made up of packages, which are groups of associated classes. Written works created mostly by other people. Regular library. It's a collection of written works created mostly by other people. While normal libraries have books, programming libraries are made up of packages.
Oh, that's cool. I wonder what that library is called. I'm gonna draw like a bookshelf in my notes. Oh man, I'm so bad at drawing.
Which are groups of associated classes. Just as a book has a central theme or thesis, a package is generally made up of alike classes that address specific programming problems. Inside of each package, we can find the individual classes that we'd like to use or read. The classes themselves are like the pages of a book that are meant to be read. Interpreted and understood. In order to read each class, we need a set of instructions that explain how that class can be used. Application programming interface. interfaces, or APIs, are a set of instructions that allow programmers to use the class. The API gives us instructions that explain what methods like println and nextInt do so that we can utilize them. We can use classes and their methods by reading the documentation that is associated with the class API. This documentation provides us with an understanding of the methods that we will end up utilizing. Not all of the methods and instance variables that have been created to get the class to work. Documentation for APIs and libraries are essential to understanding the attributes and behaviors of an object of a class. You can use Google to find out about any of the methods and more in the Java API and libraries. The definitive source for Java documentation is Oracle. A common method found in many class documentations is toString. ToString returns a string representing the class and its values.
Oh.
Printing an object directly will return the object's hash code, not the values associated with it. Writing a toString method will override the object's existing toString method. And return the values we want represented when we print. As shown here, it's much easier to see what the rectangle object's attributes are when this toString is used. When used with a specific object, Java recognizes the new toString and will use that once implemented. The string concatenation operator will, when given a string operand and a reference, convert the reference to a string by invoking the toString method of the referenced object. When we look at the next lesson, we will see how to convert primitive types to objects. Convert the reference to a string will use that once implemented. The string concatenation operator will will, when given a string operand and a reference, convert the reference to a string by invoking the toString method of the referenced object. When we look at the next lesson, we will see how to convert primitive types to objects, so that we can in turn concatenate those objects with strings. Then any type, reference values included, may be converted to type string by string conversion. Now that you've learned some string methods, let's get some practice using them in the CodeHS editor.
Oh man, that was a long video. Alright, let's do this. The method was a class implement in order to concatenate an object of the class was the output. Okay. And first occurrence of A is at 2 because it's lowercase. So it has to be this one. Also, you notice that G doesn't exist, so yeah. What would be printed by the following code snippet? Last name compared to other last name. Comparison. That's a weird word. Lexicographical. Let me. Bruh. Oops. Alright. Let's think about this. A, B, C, D, E, F, G. Oh, wait, V obviously comes after L. I'm stupid. So you take VU Unicode minus Lopez Unicode. So it's going to be negative because, I mean, not negative, positive, because this comes after. Okay. Last question. What would the output be? String school equals Rydell High School. Substring 8. What? Ah, I see. Well, let's count. 1, 3, 4, 6, 8. So, I is the 8th index, so you get everything after that. Let me count that again. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you get I school, then you get Rydell High School because it's print line. So I believe it's that one. There we go. First compared to last is not less than 0. Or wait, it is less than 0. So this is true. And then so it's gonna print true. That's gonna print false. Capital letters come before lowercase letters. That's okay. So is smaller here is going to be true. Since it's flipped here, it's gonna print false. Input 2 new words. Brr. I don't want to. I can't think of any words. Can it run if I don't input 2 new words? Oh, nice. You can do that. String word 1, word 2. You can like make them with a comma. I did not know that. So let's see. Apple comes before zebra, negative, true, false, true, false. Okay, good. So let's hit yo mama. That's one word. Yo father, that's another word. 7 means false because M comes after F. A, B, C, D, E, F, G, H, J, K, L, M, N, O, P. Yep. Okay, good. Chopping strings. String all letters equals the quick brown fox jump over the lazy dog. It's going to print it includes character at index 4 excludes character. So that's going to be space the 4, 5, 6, 7, 8, 9 quick with a space. Wait, no, it's going to be 4. Wait. 0, 1, 2, 3, 4. 4, 5, 6, 7, 8, 9, but that's space. So it's just going to be quick, yeah. 36, I literally can't count that. I'm going to assume that's dog. Get the last 3 letters in length equals length. Ooh, that's smarter. All letters substring. Okay, so that one's also going to be dog then. Lazy dog? Oh, I thought that was going to print dog, bruh. Object concatenation. Oh my god. Carol the dog. Okay, so what the frick is up with Carol and dogs? Is Carol a dog? I don't know. Yo, we got Dwayne The Rock Johnson, okay? Travis Redfin Fish. I'm sorry, I don't know who that is. The toString method is called automatically. So these are objects. Let's see what the toString looks like. Nickname equals moniker. I like that word. Bruh. Nickname equals nickname. First name plus. Can you do that? I guess you can. Wait, why didn't it just be? That's sus. Okay. I thought you'd have to put the backslash in front of that. The parentheses didn't work for me last time because it didn't recognize this as separate strings. Yeah, it does work. Oh. I was thinking you'd have to do something like oh, I see what's happening. I was thinking of it like this, and that's around it, but it's actually, you have this plus that, so it's that's its own thing. Plus that. Plus that. Okay, makes sense. So confusing for me. Exercise. This is gonna be the first exercise of the day. Okay, let's do this. The class talker is a class that holds a piece of text as one instance variable, a string called text that holds some text. Whisper. Oh, it's such a cool class. Okay. Actually, what if you wanted to do it like return but italicized? How would you do that? Set text updates the index variable text to string updates. I say text right here. Okay. Bruh, seriously? I have to go to the Oracle website. So what's it say? Go to the method summary. Okay. Did I miss it? Okay, so we've got two lowercase and two uppercase. That's the ones we want. I don't think we need the ones with the locale. That's a cool word though. It's not gonna put in this. Input some text. String words equals input. Wait, so what's the? Oh, we have to build it. Dot yell. Dot whisper. Talkie? Oh, talkie. Okay. Like talker. String yell. return text dot to uppercase. Return text dot to lowercase. Text equals new text. Oh, that's easy. The return string. I say what was it? Okay, and is there anything to change here? Enter some text. Bro, why did I have to build the set new text thing if it's not even easy? I say bruh. I yelling bruh. Whispering bruh. Maybe I should try it with like bruh. Okay. Complete the toString method for the flower class. Remember that the format for a toString method is public string toString. The toString method, what is digitalis? Wait. Oh. I'm stupid. Okay. Obscura. Is that the same thing? I'm not sure. Red foxglove digitalis. Oh, that's probably like a subclass. But not like... I mean, not subclass. Is there such a thing as a subphylum? That's probably what I'm thinking of. New flower. Print foxglove. So foxglove, red, digitalis, obscura. Oh, it's all in order. Okay. The name. Return. Name plus this plus the color. Foxglove. Oh no, red is a fox. Oh wait, I messed up. What is digitalis? The genus. Oh, so sub. What's a phylum? I was thinking phylum. Alright. Whatever. Oops. A species plus semicolon. I had to get used to typing semicolons. Like for the first day, I was just not into it. I finished all the code and none of the lines would have the semicolon. So yeah, that's just something you get used to. What the heck? The color, did I? Oops. I didn't do the instance variables, I did the... Where are those called again? I need to know this. I'm gonna look at my notes. These are called the formal parameters. I was using the formal parameters, not the instance variables. My bad. Jeez. Check code. Pink carnation. Flower names are so beautiful. They're like fancy English, if that's even possible. The class filer helps organize files by determining if the instance variable word comes before, after, or is equal to another word. You should implement the 3 blank methods. You should use the method compare to and equals to. Boolean relational operator. Okay, that's a cool word. Alright, cool, not cool word, cool term. I'm gonna take a note of that. Zebra, hippo. What? Zebra. Oh wow, that's a lot. Okay. Let's get ready. So you got word is the instance variable. You can get word, which returns it. Returns true if the word comes before other word. Returns false otherwise. How do I do this without conditional statements? Okay, so return oh wait, I'm stupid. Not. Oh, that's not a thing. Returns true if word comes before other word. So I can do word dot compare to other word. Oops. And then that changes it to a boolean. So if it does come before, I want it to be true. So if it does come before, this would be negative because you're small minus big. So if that's negative, then we want it to be less than 0. There we go. Returns true if word comes before, returns false otherwise. So if it's equals, it's also gonna return false. We can just do the same thing. Compare, oops, to other word. But this time, since it comes after, we just change that to greater than. Returns true if word is equal to other word. Returns false otherwise. Return word compared to. Wait. I guess you can do that. Or you can do the equals thing. I want to try that actually. I think both would work. You can do compared to equals 0, or you can do this word equals to other word. I'm not sure about this one actually yet, so let's test it. I'm just gonna assume that this is all correct. Bruh. Oh man, after all I said about me getting used to semicolons. Hippo comes before zebra, true. Hippo comes after zebra, false. Hippo is equal to zebra with an extra space. So that's equal to there's a typo here. Let's do it again. Hippo comes before zebra, true. False. Comes before hippo, false. Hippo comes after hippo, true. Hippo is equal to hippo, false. Enter a word, bruh. Hippo comes before bruh, false. True. Let's check the code. I want to try the other thing, so return word compared to other word. I want to see if this works as well. Bruh, really? Unexpected type. Wait, why is this unexpected type? Oh, I know. Okay. I hate that. Oh my gosh. I learned that from Python. Yeah, it does work. Okay. Well, since both work, I'll just keep the other one there. Concatenating fractions. Here's a partial fraction class. Implement get numerator and get denominator, then fill in the toString method so that it returns a fraction in the form numerator over denominator, such as 1/2 or 16 over 20. Okay, a new fraction object to what the frick? You sure he wants us to do that? That's just gonna return like a decimal, right? Okay, well, it didn't return a decimal, so something weird happening. Oh, okay. I didn't really read that. I just skimmed it. So, what's it trying to get us to do? Implement get numerator and get denominator. Okay. Easy. I keep on typing numerator. I'm kidding. Denominator. Okay. And then fill in the toString method so that it returns a fraction in the form numerator / denominator. Return numerator plus / plus denominator. Okay, so that's our class. We finished that. Then you should ask the user for the numerator and denominator for another fraction. Wait. In main, create a fraction that represents 1/2. So we're gonna go fraction half equals new fraction 1, 2. Ask for input. I don't want to separate that. Ask for input. How do I? Oh, okay. Enter the new. It's easier just to look at the example, to be honest, instead of reading the entire thing. I feel like just looking at the example gives you the sense of what you need to do. Numerator. And I messed up. System. Oh god. Print line. No, should I say numerator? Sure. I hope it's not confusing. Watch this, I'll make a pun here. Numerator. Get it? Because it's a new numerator. Int input dot. Wait, I want to try that trick I saw earlier. So, you go int numerator, and then you also do denominator. Can I call it denominator? Okay. So the trick is you just do it here, so you can just save this, and then you can see it here. Denominator. Because we already defined that it's a integer up there, right? So we can just say denominator equals input dot next. That looks much better, to be honest. I like that. Create a new fraction with the user's input. Then you go fraction dot user frac. Can I say that? Equals fraction with numerator denominator. Add the fractions, make use of the get denominator and what the? Shouldn't we make a method just to add them? Bruh. That's what I would do, at least. I would just add a method that adds two fractions in here. But I guess it wants us to do it in main, so that's what we're gonna do. I would rather make a method to do this. So we can say sum equals string sum equals, because this is not actually going to be a number, or we're going to say this is a string. It's not a double, and it's not decimal, which is a double, and it's not an integer. So we're going to call it a string. Sum equals, so you get half dot get numerator oh, this looks so messy times what was it, user frac dot get denominator, so that is going to be an integer, plus half dot, oh my gosh, I hate it when this happens, get d, that should be capitalized. I learned from my mistake yesterday. Times user frac get numerator. It's reminiscent of it, that product kind of. So that's just going to be one big integer by the order of operations, plus slash plus, we can do this in another group because it's order of operations b times d. So I'm just gonna copy this. I can't type it. Okay, w. So you can put there half dot get denom, then user frac dot get denom, and that should be the new fraction, the sum. And what I used was I just copied this format basically, except with a lot more letters, so it looks a lot worse. Print the fractions out as an equation. Remember, you don't have to. Okay, so. Two strings, so we're gonna do system dot out dot print line, I guess, doesn't really matter. Two string. Is that how it works? I don't know. I don't know how the two string method works, to be honest. Two string of see, my brain says I want to put something in these parentheses, but I guess you don't have to. Half plus two string. It's so confusing. This method is so confusing. User frac equals couldn't you just have no, never mind. I thought there was a smarter way to do that, and then I realized it didn't really work. Or, nah. Maybe. I can't think of it right now, though, because I already finished. Oops. Continue. No, I didn't mean to do that. Can I go back? I thought continue meant, like, continue working. Ooh. Where's the error? Oh. So sad. Oh. Return. That's funny. Oh boy. What did I do wrong? Oh my gosh. Get denominator, get numerator. Line 24. May have forgotten to define get numerator, or it's out of scope. Method is expecting type no arguments. Type. Oh, is it half dot two string? Is that how it works? Bruh. Does it need me to do that? Oh no. There's probably like a typo somewhere in here. Oh, I found it. Disgusting. Let's do 1/2 plus 1/2, because it's gonna give us 2/4, which I know 4/4. Bro, moment. Okay, whatever, it works. What? I'm so bad. Okay. Word games. Oh my god. See, the thing about taking any other classes, you need English, and I used to like English until this happens. Oh my god. And string called word. A constructor that takes a word to set word. Public string scramble. Cool. Public string banana split. Sheesh. Wait, why is it called banana split? Okay. Okay, so that's method overloading. Then string to string. Word is fun, then you get fun. Okay, that one's easy. I think the banana split ones are going to be the hard ones. We can focus on this after we do this. So, word text. Games. Word. What does that mean? Return. Plus word. That is super easy. It asks us to make a constructor, but we already made one. Oh no, it doesn't ask us to do that. Scramble. Okay, so let's think about this. Switch first half and second half. Man, what happens if your word is... Say like you have a word with an odd letter of numbers. What do I do? So you won't have to worry about words of, well, I'm not worrying about that, but I'm worrying about words of odd number of characters. Okay, so there's a method that lets you get the length of a word. I mean, I feel like there's a lot of ways you can do this. I'm trying to think of like a clean way. Honestly, I don't think I'm that good. I'm overestimating myself. Let's just say length equals word length, then return well, I guess do this step by step. Step 1, I don't think that's a good name, equals word dot concat word dot substring length. That's substring 2. I wonder if that works. Oh, I'm so Pega. Okay, there's an easier way to do this. Half 1 equals word dot substring 0 to length half 2 equals word dot substring length. And I almost forgot those again. Return half 2 plus half 1. Isn't that better? So we have, for banana, split returns a string that puts insert text in the word such that the character goobos. Use substring and concatenation too. I was thinking you could have just used replace, but I guess they don't like replace, so I'm not gonna use it. Because you could just replace it, right? At index, whatever. But whatever. Oh, but it replaces all the letters, so never mind, you couldn't. My bad. Insert IDX, that's insert index, okay. Part 2 equals word dot substring insert IDX. And guess what I did again? Return part 1 plus insert text plus part 2. Okay. Just copy that. Equals insert char. Insert char. Since I copied the same variable, we could just copy this. Okay, I think it's done. Let's try it. There's gonna be an error, though. There's always an error. I may have forgotten to declare length. I knew something was missing. Int cannot be converted to string. Oops. Int cannot be converted to string. Enter an integer. Wait, was this supposed to do something main? Oh, for a moment. Let's see what it's supposed to look like. It doesn't even tell us what it's supposed to look like. start with the system dot. Line. User word equals input dot next line. Scramble it. Do I really have to do this? Scramble. String scramble word equals. User word dot scramble. Line. Scramble. Ooh. Shouldn't she ask for the random word afterwards? Because, like, what if they enter 12 and then ghost? And he's doing. You already did it for me? Are you kidding me? As a programmer, I don't really look ahead in code. I literally just look at what I'm on, so I don't see what's ahead of me. Sad. What would they use? Word. I also have a user word up here. String. Insert random equals. Int string. Should add a skip over the new line above here too. Yeah. Did I write that? I don't remember that. Well, if I did write that, I'll copy it then. No! Copying my own code was a bad idea. Okay, I think that's it. We are done, boys. Let me see the errors. Scramble or anything. This is not scramble. What? Oi. Does that not work? Oh! Oh my god. Wait. Oh, I wouldn't have caught that by myself. I needed that in the catch it for me. String word. What the frick? Enter a word, yo mama. What? What did I do wrong? Stop. Do be scrambling it. Print out the scrambled word. What? Oh, wait, what the heck? Oh, I thought that meant... Okay, never mind. I thought that meant skip a line in the console for a second. 1. Entire character. No. What is that? Okay, before we do that again. My Scrabble don't work. Return half 2 plus half 1. Sorry if you're confused about that, my bad. Yo yo meow meow. Yay. Index -1. Negative. What? Bruh. Wait, what? Why did I say 36? Really? What? Oh my god. How does that happen? What in the world? Dude. Man.
그러니까 시원하게 되잖아.
I'm recording. Why doesn't this just work? Dude, it does work. This thing is capping. Okay, wait. I'm just gonna copy this to see if it works. Ghost, right? It rounds it? Oh. Okay. Enter integer. Okay. Go boost? Did I get that? Enter a character. Do I get go boost? Bruh. This is broken, man. This test case, this is broken. And why does it do that? Testing, manus. Oh my god. Alright, man. Bro, what? Yo, is my snip tool broken? Uh-oh. I mean, I guess it's not broken, it just doesn't. Oh, why does this happen? Okay, whatever. Yo, wait. Why is it image options? Broken program, whatever. That was so long. I completed 2. I didn't even complete 2.8. And it took me like a couple hours, man. That was so bad. Alright. Let's keep on going to wrapper classes, integers, and doubles. Wait, actually, before I do that, I'm gonna go use the bathroom. Hold up. Okay, I'm back. Boys back.
Hi, in this lesson, we'll look at wrapper classes.
Hey, yo, what?
We know that there are differences between Hi, in this lesson, we'll look at wrapper classes. We know that there are differences between primitive and reference types in Java. Each of the primitive types, int, double, etc., are built into the language, while each of the primitive types differ. Hi, in this lesson, we'll look at wrapper classes. We know that We know that there are differences between primitive and reference types in Java. Each of the primitive types, int, double, etc., are built into the language, while objects and classes are created by the programmer. One problem that comes from having both primitive and reference types is the fact that some objects will only interact with other object data types. Array lists, for example, are a common data storage type that will only store object data types and not primitive values. But what if we wanted to store those primitive values in an array list? Luckily, we can actually convert primitive types to object types using something called a wrapper class.
Primitive to object.
For every primitive type in Java, there is a built-in object type called a wrapper class. Every primitive type in Java, there is a built-in object class. For every primitive type in Java, there is a wrapper class. For every primitive type in Java, there is a built-in object type called a wrapper class. Object types, using something called a wrapper class. For every primitive type
Sometimes I wonder, would it just be faster to take notes on like a Google Docs instead of a notebook?
in Java, there is a built-in object type.
Oh, I forgot to do my AOPS. Uh-oh.
Called a wrapper class. The wrapper class is a class that can contain
Oh, like a food wrapper. I'm so smart. Or wraps. That's a nice word. As an object. I can kind of see how it works. You just make a class called a wrapper class, then you say wrapper dot that is the value, but it's an object. Yes.
primitive data types as object data types. Each Java primitive has a corresponding wrapper class as noted in the table. Notice how the primitive types are lowercase, while the wrapper classes are all uppercase.
This is called numeric wrapper classes. When I think of wrapper class, I think of Snoop Dogg. I don't know why. Or Killy. You guys should listen to AC Young Bubba. I think that's the rapper's name. I don't have a ruler. Hold up 1 second. Give you my job coming up for this one. When I hear a rapper, I think of, oh man, Lil Loaded, bro. I saw him on YouTube today. Sad. Bullying. When I hear bullying, I think of someone's bullying someone. Why are you bullying? Is that good? Bro, they really had to write out every single word. Why couldn't they just leave char as char, int as int? Like
We will only study the integer and double wrapper classes, but it's good to be aware of the others. Wrapper classes provide a way to wrap primitive values in an object so that primitives can do activities reserved for objects, such as being added to an array list collection. We will get into other data types later in this course. Wrapper classes provide an assortment of built-in utility methods for primitives, like converting primitive types to and from string objects or comparing various objects. Sometimes you may need to create a wrapped object for a primitive type so that you can give it to a method that is expecting an object, and this is where wrapper classes can help. We can instantiate wrapper classes the same way that we do with other objects. Creating an integer object requires us
You see this? Instantiating an object of a wrapper class. That's 7 words, man. Oh, at least they made it easy. Thank you very much. Integer y equals new. Oh, yeah, I was thinking it would be something like that. But then, is it built in? Is it like part of the system package?
To use the new operator followed by an int value. Just as with other object types, we can only input acceptable data types. For wrapper classes, the data type must match the primitive data type. Types. Integers can only be given int parameters, and doubles must be given double values. We can distinguish the primitive types from the wrapper classes by the lettering. If the data type starts with an uppercase letter, then it is a wrapper class. Otherwise, the data type will be the primitive version. Just as other classes have methods, the wrapper classes have methods that can be utilized.
Ooh, I see. I feel like I've seen some of these before. Yeah, we've seen the min value and the max value before, I think. How do you return an integer, like a capital integer? Oh, right, you have to do it as an object. Sorry if I learned too slow. I feel like I'm a fast learner, but I have to take my time with lots of details to learn the best I can.
Let's discuss the integer.min and integer.max values. We looked at these values in lesson 1.5. Note the integer class designation at the beginning. These can be used to assign variables to the max and min possible values and are useful for upper and lower bounds of arrays, which we will discuss later in the course. The next method we'll look at is the int value method. We will look at the double value method as well, because they both serve the same purpose for the two different wrappers. The int value method returns the numeric value represented by this object after conversion to type int. The method does not accept any parameters. The method returns the numeric value which is represented by the object after conversion to the integer type. Int value converts the object integer 68 to the primitive type value, which is then assigned to int I. I can then be used as a primitive value and is printed in the subsequent line of code. A similar method exists for the double class, where the double value is converted to the primitive type and then can be used as such. Having to convert between object and primitive values is a can be used as such class, where the double value
Double D. Double object. Double value. Okay.
value is converted to the primitive type and then can be used as such. Having to convert between object and primitive values is a lot of work. Luckily, Java has a way of
could be tedious. Like runtime. Runtime's a cool expression. Why is it called autoboxing and unboxing? Shouldn't it be wrapping, like auto wrapping and unwrapping?
Recognizing when a wrapper object needs to be converted to a primitive and vice versa, and automatically makes that conversion happen. This automatic conversion process is called autoboxing and unboxing. Autoboxing includes converting a primitive int to an object integer and a primitive double to an object double. Autoboxing is done automatically by the Java compiler. Instead of having to write the full constructor, Java will convert the primitive value to the wrapper class if the data type declared at the beginning of the variable corresponds
Oh, it's not wrapping, my bad. I thought it would like automatically wrap it. Oh.
to the correct wrapper class. The Java compiler will also apply autoboxing when a primitive value is passed as a parameter corresponds to the correct wrapper class. If the data type declared at the beginning of the variable corresponds to the correct wrapper class.
I said auto wrapping, I got so confused.
The Java compiler will also apply autoboxing when a primitive value is passed as a parameter to a method that expects an object of the corresponding wrapper class.
Are you kidding me?
We will learn in greater detail about array lists, but for now, we just need to know that when instantiated with integer, array lists are only supposed to accept integer value types as acceptable data types. When we initially print the array list, the list is empty. When we try adding the primitive variable, we can see that the value of primitive was successfully added to the list. This is because Java automatically converted the value of primitive to the integer class.
Seriously, then
so
why is
that
it called
Java sees
autoboxing? Why
the
is
list
it
is
called
empty.
auto-wrapping?
When we
But I'm happy about that. I'm not complaining. I'm just curious.
try adding the primitive variable, we can see that the value of primitive was successfully added to the list. This is because Java automatically converted the value of primitive to the integer class so that it could be added to the array list. Unboxing is the reverse of autoboxing. Unboxing is the automatic conversion that the Java compiler makes from the wrapper class to the primitive type. This includes converting an object integer to a primitive int and an object double to a primitive double. Instead of having to use the int value method, as we did in a previous example, we can actually assign an integer object to a primitive variable, and it will automatically convert it to the correct type, object as primitive double. Instead of having to use the int value method, as we did in a previous example, we can actually assign an integer object to a primitive variable, and it will automatically convert it to the correct type, object as we did in a previous example. We can actually assign an integer object to a primitive variable, and it will automatically convert it to the correct type. This example shows unboxing when an integer object is assigned back to a primitive int type. The Java compiler takes care of the unboxing conversion at runtime. The Java compiler will also apply unboxing when a wrapper value is passed as a parameter to a method that expects a primitive value. In this example, the rectangle constructor is only supposed to accept int values as actual parameters. The wrapper class integer is unboxed when input to the rectangle constructor into a primitive value type, which is then stored as the width value in the rectangle. Autoboxing and unboxing allow us to use primitive types and wrapper class objects interchangeably, which is when a wrapper value is passed as a parameter to a method that expects a primitive value. In this example, the Java compiler takes care of the unboxing conversion at runtime. The Java compiler will also apply unboxing when a wrapper value is passed as a parameter to...
Okay, wait. That should say unboxing. That's... I should have made the own pages for...
a primitive int and an object double to a primitive double. Instead of having to use the int value method, as we did in a previous example, we can actually assign an integer object to a primitive variable, and it will automatically convert it to the correct type. This example shows unboxing when an integer object is assigned back to a primitive int type. The Java compiler takes care of the unboxing conversion at runtime. The Java compiler will also apply unboxing when a wrapper value is passed as a parameter to a method that expects apply unboxing. when a wrapper value is passed as a parameter to a method that expects a primitive value. In this example, the rectangle constructor is only supposed to accept int values as actual parameters. The wrapper class integer is unboxed when input to the rectangle constructor into a primitive value type, which is then stored as the width value in the rectangle. Autoboxing and unboxing allow us to use primitive types and wrapper class objects interchangeably, without having to perform any casting explicitly, thus making it easier for programmers to write cleaner code that's easier to read. Just like the string class, the integer and double classes are part of the java.lang package. Because the
So that answers my question from earlier.
classes are part of the java.lang package. Because these two classes belong to the java.lang package, they are built into the Java platform and can be used without having to import them. Now that you've learned about the integer and double classes and autoboxing and unboxing, let's get some practice using these concepts in the code editor.
Alright, I have to go eat dinner, but I'll continue recording day 2, part 2, after I finish eating my pizza. Alright, bye.